let's talk about why we are going to Mars in the first place, to look for evidence of life. If we think about early Earth, we had water, we had lots of energy from the solar radiation coming down, we had impact events, there were volcanic eruptions, all sorts of things were going on. There was heat sources, there were nutrients everywhere, and somehow, some way, life took hold. Mars happens to be our close neighbor, and we have suggestions that tell us that it might have been much the same way. Water, energy sources, volcanism, impact events, nutrients abounding, everything is in motion. Could life have started on Mars too? Let's assume that life has existed on Mars in the past. What ancient biosignatures might we actually look for? Life is selective at what type of molecules it uses, and that's what we would look for. That type of information tells you about biosynthesis. It gives you first insights into metabolisms. And that type of information is incredibly powerful in understanding an ecosystem. Microfossils. If we have the right type of microscopes, we might be able to uncover those. Every biologist that I have talked to who studies extreme environments says they want to see a cell. If we have microorganisms living in a wet place, they might make a mat. Those develop textures that might get preserved. These are just a few examples, but these are the types of things we look for in trying to understand what life was like in an ancient environment on Earth. We should look for this type of stuff on Mars. It is amazing to think that 10 years ago, we had just figured out that, hey, there's water on Mars, and now we know it wasn't just there, it was sticking around. It was doing things, it was changing the surface of the planet. Hey, there were places life could live here. We have figured that out. Curiosity rover, which is on Mars right now, drilled that hole. They went through the red crusty layer that we see from here as the red planet. And lo and behold, right below the surface is this dark gray sediment. All of that chemistry, all of that diagenesis, all of those changes that are happening at the surface because of radiation, because of oxidants that are destroying the record we are trying to get to, might actually have not been altered. Deep down, we might actually find something closer to what we find on Earth, something that hasn't been broken down, the original stuff of an ancient ecosystem. We are looking for evidence of life. And this, honestly, could be ancient life that we're looking for, or modern life. Well, we don't know. But in either way, this is a pretty exciting approach.